Hey everyone, welcome here. I'm Samuel, and I simplify complex IT concepts and I bring you cutting edge strategies that'll help you to transform your business. Today, we're going to deep dive into the world of insurance technology, specifically how insurance companies can shift from their traditional monolithic architecture to agile, scalable microservices through a strategy called Decompose by business capability. We'll talk about that in more detail when we go deep into this video. If you're working in the insurance sector or you're an IT architect aiming to modernize legacy systems, then this video is for you. First, let's understand what we mean by monolithic architecture. In a monolithic setup, right, all the functions like the sales, the customer management, the compliance, the marketing, right? They are tightly coupled in one single application, like the one you see in the left hand side. While this design was sufficient in the early days of software development, right? It has now become a bottleneck. Why? Because of scalability issues. For example, you can't just scale just one part. The whole system needs to be scaled up. And maintenance in a monolithic is sometimes a nightmare. A single bug fix, could impact the entire application. Talking about slower updates, right? Rolling all new features means redeploying almost everything, even the ones that you haven't touched. So these are some bottlenecks we have over the monolithic architecture. So what's the solution? The solution is move to microservice architecture. Instead of having one giant block of code, right? We break them into business functions. For an insurance company, let's say, the business capabilities might look like this, or the business functions might look like this. Sales is one small business function. They deal with policy, they deal with onboarding, and then customer management is another small business function. They deal with customer data and updates to the customers, and then compliance is another small business function. They ensure legal and regulatory adherence within that system, within that business. And marketing is another small function. They manage all the campaigns and all the different outreaches. So each of these small components are called microservices. They are very much independent from each other. They are very much independently deployable and they are very much independently scalable. Now let's talk about the benefits of microservice architecture. So why is this a game changer? Here are some few benefits of microservice architecture. Scalability. Microservice architecture can be scaled individually. We can scale sales or marketing separately based on the demand. Not an issue at all. It also reduces the time to market, otherwise gives us faster time to market. Updates on one service, right? We can do that without redeploying the entire app. That's time to market. And resilience. If, let's say, the marketing component crashes, compliance and sales, they can continue to run smoothly with no issues. And talking about technology flexibility, right? If you want Node.js on customer management and Java for sales, go for it. You can do that. It's also easier to maintain because it's all small. The code base is isolated, which means that it really helps us to debug any issues faster. It really helps us to update those individual components faster. These are some benefits of microservice architecture. Now let's talk about how to implement this transformation. That's the big question. So to make this transformation successful, right, we'll have to follow these six strategies or six strategic steps. First, we'll have to identify the business capabilities. We'll have to work with business stakeholders to list out the key functions. Secondly, we'll have to do something called as domain modeling, meaning create a clear boundary for each of those business functions. And thirdly, we'll have to do something called as service development, which means we'll have to build each capability as an independent microservice with its own database. So at a later point, we can do something called as service development and service deployment. And then instead of load balancers, we'll have to move to API gateway to manage all communication between the client and the microservice efficiently. Sometimes these individual components need some data synchronization between them. For that, we could use Kafka or even SNS for all those real-time updates. Monitoring and security also needs to be imparted. We can use tools like Prometheus for monitoring and IAM for all those secure access controls we may need. Let's look at a real world example how this benefits an insurance company. Let's say an insurance company X had a monolithic application like the one in the left hand side that handle policy, sales, customer data, compliance checks, and marketing campaigns. The disadvantages is it's all in one massive code base, right? After we have decomposed it by business capability and moved to microservices, right? The insurance company gets benefited by a 30% faster onboarding process in sales because it's an individual component. It gets benefited by reduced downtime for customer management because it's an individual component. It gets touched or rebooted, or a downtime happens only when we need to do some deployment on the customer management segment alone. It doesn't go down often like in the older case. And the company gets benefited by more agile responses to regulatory changes in compliance. And we can also automate marketing triggers that can increase the client engagement. We can modify or modernize the marketing part of it alone so it can increase client engagement. So in short, right? In short, the insurance industry is evolving rapidly and transforming legacy systems into microservices through Decompose by business capability is the first step towards modernization. This not only enhances agility but also future proofs our business in a competitive market like the one we have now. Join me next time when I talk to you about database strategies for microservices in insurance architecture.